what's going on with my stream tonight, but it keeps cutting out on me. Something's not working. I'll have to look. It's either my internet connection or maybe I need to update something. I don't know why it keeps going out. So I'm going to have to stitch all these videos together, which is going to really be a pain in the ass. But anyways, I'm on the last cap. And we're looking at the glue that's starting to go bad on the edge of the board here. And it's really not touching anything. Like, there's no through holes underneath that I can see. But what I'm going to do is I'm just going to clean up the part that's brown. And I'll just leave the that last little bit on there. Let's just do that real quick right now. Heat it up and pull it off. If it all comes up, it all comes up. But that little bit on there won't hurt nothing because there's nothing for it to contact. So as I'm scraping up the glue, I'll just use my pliers and just kind of grab it and rip it off. So we just cut the brown stuff off of there, and then I'm just gonna make a little chop there just to kind of clean it up. But there was nothing underneath it, so we weren't really risking shorting anything out. It was more just a cosmetic thing. We do have the little resistor. It's a jumper. It's a 0 ohm resistor that connects this leg to ground. I'm going to bend the capacitor leg over a little bit. Just because it's barely touching. Like, sometimes they're overlapped really good, sometimes they're not. So space it off the board and give it a little bit of overlap. And that way we'll get a really good strong connection between there. It's not like critical, but makes for a better connection. So we'll solder that guy in. I gotta keep an eye on this stream too, so I'm gonna be a little bit distracted. I'm gonna keep looking up because I don't know why it keeps dropping out. That's the third time tonight it's dropped out. That's never happened before. Could be that I need to update the broadcaster. Either that or my internet's going wonky tonight. But downloads have been good. I don't know what's going on. It says I have a great connection. Could be a YouTube issue. I don't know. Something's not right. We'll just leave it at that. Something not right. So we have one more cap. And then we can reassemble the audio board back in. We won't be able to put the power supply in, but we can get the amp board back in. This last cap is really hard to get to. I really need to make a curved nozzle for this. That'd be sweet. Guy I work with is a master machinist. I bet you he could make me one. Even if it was a 90-degree angle, it would still work. What I could probably do is take one of these long tip ones and just heat it up with a torch. Just whack it with a hammer. That would probably work too. Alright, so this last one is 4.7 microfarad at 50 volts. Which we have. We have plenty of those. And I believe this is for the IR circuit. If you have the remote. I have a Logitech Harmony which actually works with this. unfortunately they disabled those, or they stopped manufacturing those. I thought those were, it was a great idea, but I guess everything's like cellular based now. My S5 phone had an IR blaster in it though. I could do the same thing straight from my phone, which was kind of cool. Alright, lead trimming time. Snip the leads, and then we will start reassembly. And hope the stream doesn't cut out. What an adventure tonight. We still don't know if this thing works or not yet. We won't know until we get the power supply operational. Alright, that's all the leads trimmed. Everything is good there. I'm going to take these clamps out because I'm going to put some like thread locker goop on them. Not really thread locker though, I just put a drop of E6000 on them. E6000 works really good to hold these in place. And I want to smear a little bit of the thermal compound around to make sure that they get a little bit of thermal paste on them. They don't need a lot, just a little bit. People go way crazy with the thermal paste, and that's 100% the wrong way to do it. The thermal paste is only supposed to fill in the voids between the two surfaces. It's not supposed to cover the surface completely. It's mainly the PC guys. PC guys just totally blob that stuff on. And you're actually reducing your cooling at that point because it doesn't have the same cooling capacity as a metal-to-metal contact. So pro tip for you guys. Oh, this one's really hard to get out. My fingers are going to be like red. Short-handled screwdriver would be a little bit easier and get a little more torque on it, but I don't feel like going upstairs right now. Stream looks a little more stable. I don't know what changed. Alright, let's get the tools out of the way. We don't need those. Get our screws out of the way so we don't scratch the plate. And we got to get the glue out of there. That's got to go. And unfortunately, it's going to involve... Yeah. There's all kinds of stuff on here. So we're just going to pull everything up, clean it, and start over. You got to be careful with these ceramic pads because they will crack very easily if you're not gentle with them. This one has glue underneath it, so yep, there it goes, crack. All because of that blob of glue right there that I can't get off. Luckily I have some spares, but there's a nasty blob of glue right there. And since it cracked, it upset me, so I'm going to turn my temperature up to like 500 and just burn the living life out of it. I wasn't lying. I did turn it up to 500. But you got to get it hot though, because this aluminum plate is a giant heat sink. and it will not allow you to get the glue off. So you need a little more heat than normal. This is that same damn glue that kills everything. It's glued the ceramic pad down. I can't get underneath it to get it off. And I have a razor blade. Can't get under it with a razor. How crazy is that? Well, next step is going to be to use the hammer. A little gouge into the plate there, but that won't hurt nothing. We'll smooth that out. We will smooth that out. So this guy wasn't getting any cooling because he was just flat out glued down, and there was no thermal paste under it. It's just glue. How that's a good idea, I don't know. You gotta be careful when you're doing this. You don't want to get a piece of the ceramic stuff shooting in your eye. That would be a bad day. I've never had one like this. Worked on a lot of plates, never had one that was this bad and glued down like this. We'll scrape all the thermal paste off. We'll put all new thermal paste on. I'll put a new ceramic pad. I can do silicone pads too, or mica. I have all the above. I gotta get this off. Dang, that was on there. That last little whack was just to chop the little chunk of aluminum out that was missing from gouging the razor in there. I cannot believe how bad that was. Well, I can rest assure you that you weren't getting any cooling on that one, because that was just buried in there. So there's a little scratch in there. The razor blade took a little chunk out, but that's not going to hurt nothing. We will put a new ceramic insulator on there, because this really is an insulator. I don't know why they use ceramic pads. Actually, you know what? Let's see what I got. Maybe I'll put mica pads on this one. I do have plenty of ceramic ones, but I would rather put a mica one on there because the mica ones are better. And since I broke one of the ceramic ones, I don't want to dig through the whole pile with all that goop on there trying to find the one that actually fits. So we can do silicone or ceramic, but either way we'll do a good quality repair. No need to worry. Let's see, I got yeah, we'll do mica. Put some mica ones on there. Those should work just as good. I've used them many, many times before. Cool little project. I don't know if I've showed this in any of my videos yet, but I was having problems keeping all my little tubes of stuff organized, so I 3D printed this little holder thing. Works awesome. Holds all 3 different types of these like little syringe things. Helps me stay organized. I just got to label them so I know what's I got in each one of these. One of them is thermal paste. One is silicone. This one's silicone. For sure. So that means this has to be thermal paste. At least I think it is. Find out right away when I take the tip off. Yep, that one's thermal paste. Not too sure why the tip is clogged up though. And of course I don't have any clean tips to it. Well, we'll just use the end of the applicator. Here's what we're going to do. One drop. That's all you need. One drop, and we're going to smear it on there. These actually sit below the mounting holes too, so we got to make sure we rotate them right. These don't use through clamps, they use the clamps that just press on the top. Yeah, you don't need a ton of thermal paste. This is Dow Corning 640. You don't need to go crazy with the paste. This is the stuff I use. Good stuff, not cheap. If you want to go crazy, you can use like the PC stuff, Arctic Silver, or what is this, Phoenix 7. You know, you can use the good stuff if you want, but there's really no need for it. You don't need to go that overboard. This is a silicone-based, yeah. It's a silicone-based compound, so it's going to have like a little bit of a slippery texture to it. But it's good high heat. It should remain, you know, somewhat fluid for a long time. I use this on my computers. I use it on my mining rig. I use it on a lot of different stuff, and it's good. It's good thermal compound. You don't need, you know, anything crazy. That little scratch that's in the plate that I made with the razor blade, that ain't gonna hurt nothing. It will affect the thermal performance of this by none. If you were really concerned or worried about it, you could fill that void. You could use some adhesive. You could use what's it called? Arctic Silver ceramic epoxy adhesive. That would work just fine. Throw these heat sinks into the heat sink junkyard. Misplaced my tweezers again. Yeah, ceramic is an insulator. they put ceramic on the front of the spaceship to keep the metal from melting, so it's not really a good passer of thermals. Mica is definitely better, silicone better, direct contact obviously is the best, but that would cause a short. Captain tape works real good. I've seen people use that. They'll, instead of anything, they'll just put a layer of Captain tape down and just go through that. It is an insulator, but it's so thin it allows the heat to still transfer through the plate. These mica ones are good though. I mean, they've used mica insulators for years and haven't had any problems. Alright, here we go. Nope, just kidding. Just kidding. I got that thermal stuff everywhere. Literally everywhere. Definitely need to wash my hands really good. I just want to do a very rough and dirty cleanup on these. Mainly just the bottom surface where they're going to contact the new insulators. Or isolators, I should call them. They're not really insulators, even though they technically are. Electrical insulators, I guess. Or electrical isolators. Whatever. The little pads we just put down. Alright, got most of the thermal goop off. I'll put a little drop of on each one of these. Again, we're not going nuts like they did from the factory, just a little bit. It's a much cleaner job, and I promise you it will function exactly the same. This is not a mission critical application here where, you know, if it gets 1 degree C too hot, you're going to have a meltdown. Oh, I'm getting that stuff all over my screwdriver. I should not have touched the thermal paste. I made a mistake there. I'm going to screw this in until it's kind of snug. I'm going to clean myself up again and clean my screwdriver because I don't want this crap getting everywhere. It's like super slippery. Shines the screwdriver up nicely though. My cheap Amazon screwdriver that I've grown to love. The only screwdriver I like more than this is my great-grandpa's wooden handle Stanley, but I've tried to stop using that because it's got sentimental value. Actually gotta loosen this guy a little bit. And that one doesn't have a magnetic head, this one does. Alright, now it can fight me all at once and those screws are going in. Alright, just snug. We don't want to strip them out. You know, give it a little... That's good. They are easy to strip. So now we want to check and make sure that we get full contact with our heatsink and nothing's on the plate. So I'm just going to pop all these down and look, and then I'm going to adjust the mica insulators below. And I'm only verifying that we have full coverage through the base and that they're not going to short out. And that should be good. Again, it's not really mission critical, But you do want to make sure that you get a good good insulation. You don't want to short out to the plate. Put these are the worst clamps. They work, but if I had a choice, I would never use these clamps. They're great as long as you don't tighten them too much. The second you over tighten them, they lose all their clamping force. It's just a piece of sheet metal with a bend in it. And to get the clamping force, it relies on deflection. So the plate bends just a little bit, and that's what clamps down the MOSFET. But if you bend it too much, it actually forms a crease in the metal and then stops acting like a spring. So it's not my preferred clamping method. I like the bar clamps that the sub 10s and sub 12s use. Those are very effective. They worked well. I mean, these work. They leave a lot of room for error. And they can strip out pretty easy too. So the reason that Klipsch glues them down when they clamp on the MOSFETs is they know that they don't have a ton of clamping force, and they don't want them to come loose. So if you put a drop of glue on them, that's how they cheat to retain the clamping force and not worry about them coming loose from vibrations. I'll look on my shelf and I'll see if I have a spare supply. I might have one that I salvaged from something. Actually, I might have one on the floor right to the left of me. Got parts everywhere. I'm gonna get rid of some of this stuff. So yeah, when you're tightening up these MOSFETs, just definitely don't go too tight. You gotta go by feel. Like, it's very, very easy to... I'll have to see if I have an extra one of these in my box somewhere and show you what happens if I over tighten them. I'm not going to do it on this though, I'll do it on a different plate. I want to get this guy back together and maybe fire it up. We won't use his power supply. Maybe we will. I don't know. We'll see. That supply is missing 4 of the filtering caps on the DC output, so I mean it'll still work, but I don't know if there'll be noise or anything in there. So alright, plate is reassembled. Let's take a second and clean up the mess that I made. And then we'll do a little 2-minute evaluation on this guy. Cover what I did in the previous streams that kept getting all gnarly and freaking out on me. Whoops. Just threw my ruler in the garbage. Don't know why I did that. Save my cap scraps. I should save those leads. Those leads are scrap metal. Not worth really anything, but throwing them out doesn't do them much good either. Alright. Feature board. Inside plug. Always make sure the feature board goes to the inside plug. I know it's ass backwards and it doesn't seem like it should, but that's how it goes. Then main. This is from the power supply. That's our plus minus 15, and this is power to the amp board. Speakers go in the bottom, so like that. Alright, let's see what we got here. Is this a... oh, that's no good. This one has not yet been repaired. This is one of mine. I'm sure the customer's other amp behind me has a bad supply as well. I'm going to check one more spot on my shelf and see if I have one. If not, we will just power it up real quick with the original supply. Let's see, that is all newer and larger stuff. So I do not have one readily available. So just to show, I don't like leaving videos open-ended, even though half of this video is missing and a lot of you guys are like, what the heck's going on? Let's just do a quick little test here. And again, this has to come out because I'll give the overview. So what we did in the previous streams that cut out, I removed the PDC board, cleared all the glue out of here, removed the caps, cleared all the glue out of here, recapped this board, removed the glue around this guy here. We tested the PDC in another plate amp. We know that's good. And then we had some ceramic caps down here that were blown up. These are 0.1 microfarad. The original ones were 100 volt. I'm replacing them with 200 volt because this cap is rated for 160. The original ones were only rated for 100, at least according to the schematic. So a little bit of an upgrade. They're more of a safety measure than an upgrade. But that's what we did so far. So we're missing, a few film filter caps. It shouldn't matter. The device should still power on. I'm not going to run it like that, but we are going to test. One other thing you got to look for too is the inrush limiter down here, and you got to check it for burns. And it looks good. I don't see any burns on it. It's usually readily noticeable if they have failed. That one looks good. I like my unprotected power leads much better than these. These are hard to get on. They're good connectors, but they need to be worn in a little bit. I'm not even going to plug them all the way down. Alright, so we're only looking for power on this. I know it had no power before. I don't know if it had a blown fuse or not. We're bypassing the fuse right now. Somebody tell me what those comments are. What does vor.ngo mean and vor.red? What does that mean? And it's always like, it looks like somebody from Russia's putting them in there. Is that like a translator or something? I thought most Russian people can speak English. Alright, here we go. We're going to power it on, current limited, and see what we get. Okay, so we just got a flash. So just a flash. And okay, so here, watch this. Power on. Power off. See how the screen just blinked like that? So I know what that problem is and I know how to fix it. We're going to we got to disconnect this board again. We got to take the power supply out. These caps on here are still holding a charge. So you got to be careful when you're at this point. You got to get the little locking tab depressed in to pull these out. Alright. I'm not going to discharge this because we're going to put it right back in here in a minute. Alright, let's fix that blinking LCD issue. And I can't remember if I've covered that or not before. But to fix that, we got to go to this guy here, voltage regulator. And there's two ways to do this. There's a right way and a wrong way. I'm going to show you the right way. So the right way is I'm going to put the cutters flat against the part like this. And right above the pad, I'm going to snip the legs off. There's one. There's two. If you don't do it that way, you're going to rip these pads off the board, and you might as well trash the board. And to get this off, I got to turn the solder sucker on. We're going to need the solder sucker because we need the heat. I'll show you how to get this guy off. In the meantime, I'm going to grab a replacement. That's a 7805 voltage regulator. And I keep those in stock because I go through a lot of them. Russian link is... oh, thanks, bub. Alright. NSW spam will be deleted. I don't want that crap in my channel. Thanks for letting me know that. So I'm waiting for my solder sucker to heat up. We're almost there. And this is a two-handed job, so once that gets hot, so we cut the leads on the dropout. Alright, we're at temperature, so what I'm going to do is I'm just going to blob a decent amount of solder on the tip. You could do it with an iron too, it just works better with the solder sucker because it gets hotter. And I need like two hands, but I'm going to heat up the heatsink tab on there. Pretty good, and then the part just pops right off with a pair of tweezers. That's the safest way to remove those. And then when you're done, you can either use solder wick or, you know, whatever your preferred method of, you know, removing solder is. One of those little vacuum suckers, one of these things. But the blinking screen issue is almost always the voltage regulator. The little pads that we cut, we got to get those off, so just pop them out. And I have wick somewhere. I'm just going to wick one pad. Wick the one that's closest to me. And then we'll throw the new guy on there. One pad at a time. So the pad that's closest to the cap is the hardest one to get to, so we'll solder him first. I could probably zoom in on this too. It's going to be a little shaky because I don't have real good support here, but let's get in there. There we go. So I'm going to hold it with the tweezers, get it lined up. And then sink one leg on the pad, and then I'm going to check alignment. I don't want it to be crooked, I want it to be centered real nicely on the heatsink. So we'll just heat it and twist it until it sits where I want it to sit. We're going to go in just a little bit. Alright, that's good enough. So now I'm going to push the device down, heat that pad, make sure it's sitting flush with the double check and make sure it's straight to your standards. Solder the other leg. You can put a nice fillet on these too. You don't have to do one of those little baby soldering jobs like they had from the factory on there. You know, get some solder in there. It ain't gonna hurt it. And then for the thermal pad, what I do is I'll feed a blob in there, and then I keep feeding it as I'm running the iron across the top so it wicks under the thermal pad. You get that really nice, I know it's hard to see, it's not focused real well, but you get a really nice like fillet on the front end. Oh, that's still hot. Don't touch it like an idiot. But we'll give that a second to cool off. We'll expedite the cooling with a little bit of evaporation. And at the same time, we'll clean it up. A little alcohol on there. That will really help clean it out, or help cool it off and clean it up at the same time. It's already, it's already cool enough, good to go. Okay, that is how you repair the blinky screen issue. So I'm glad through all the technical difficulties the total video wasn't a loss. And I'll try tomorrow to stitch these together, but for now let's give it a test. We're not going to do a full test just because we're still missing the 4 filter caps on the supply. But we can just do a functional test just to make sure that the supply is back up and running and it's working as intended. So, got it hooked up. Let's zoom out. And you'll be able to see the screen, I think. Yeah, screen's in camera. So here we go. Everything's hooked back up. Positive and negatives are correct. We're going to go current limited for now. There she is. RW-12D. Well, here's another tip too. If you're working on one of these, power it on without anything hooked up, because people always leave the volume like way maxed up. I always put it down to 32 and then I change all their settings. Flat. LFE mode. Phase it down to 0. Save. The reason I do that is because the caps have all been replaced, so the phasing might be off a little bit now. The crossover points might just be changed a little bit, so you know, when you change the cap, these caps are going to need a break-in period. So, you know, when you power this sub up, you're going to have to get some hours on them till they sound their best. Not that it's going to sound bad, but there's definitely a break-in period for electrolytic caps. On a sub, it doesn't really matter as much. On a full-range amplifier, it matters a little bit more, but still. So I put the settings all back to basically 0, and then when you get the amp, you can retune it to, you know, how you like it, the way to sound. But So, brief overview again. We repaired the power supply, recapped. We found some damage on the board from some ceramic caps that failed. I have those on order. We recapped the I recapped the amplifier board. That was done off camera because my stream kept crashing. And then we did the input feature board. So this is basically a brand new amp. It should function like a brand new amp and get plenty of service out of it. So when I get those through-hole caps in sometime later this week, we'll pop those in and then we'll do a review on this, and then I will repair the twin to this, which is too far away to grab right now, but the guy sent me two, so the testing of this one will be part of the next repair on that one. So for now, I'm going to power down. There we go. You can see I'm comfortable in my pajamas tonight. Alright, we're going to power down and get cleaned up. And then tomorrow, since we're not going to be working on this, I think, let's see what we're going to work on tomorrow. Let me go grab a box. This is a heavy one. Tomorrow we'll do a Velodyne. I got a Velodyne that's in pieces in this box. That'll be fun. This is one of my shelf queens that's been on the shelf for a while. I can see I started it, but I never finished it. So we'll dig through this and we'll finish this Velodyne tomorrow. Or I'm sorry, Sunfire. This is a Sunfire. I think it's an HRS 10 or 12, or I don't know. We'll get into that, but that's tomorrow's project. And that amp is a personal amp that I own, so that will be up for sale. So I'll mention that also tomorrow after it's done and repaired. But all right, let's see. It's 3 a.m. It's time to call it a night. Go to bed. I gotta get up and work tomorrow. So appreciate the tune-in for those that were able to stick it out through the crashing of the stream. And we'll see you tomorrow. Remember to like and subscribe. If you have any questions or comments, please post those below, and I'll try to get back to you as soon as I can. If you're waiting on repairs, I just sent out a new batch of requests for people on the list to send them in, so I'm trying to jam through the list as best I can. We'll get to you. Just appreciate your patience, and again, thank you. So we will see you guys tomorrow. Have a good night.